Good morning, good evening, good afternoon, boys and girls. So today's lesson is about HSRP lab. We will be configuring a lab, but before that, I will have to tell you an anecdote. This happens back in 2013 to 2015, if I'm not mistaken. No, it was 2011 to 2013 when I was working with the bank as a network engineer for HP Enterprises, outsourcing for Bank of America. Now, the biggest mistake was that I powered up an interface during a maintenance window, but I didn't document it. And that was my mistake. It wasn't that the electricity, there was a power blackout, a power outage, or that I was bouncing interfaces at the back during the maintenance window. The main problem was during that period of time, I didn't document it, everything that happened in the ticket. So just remember this. If you don't document it, it's like it never happened. So that's a little bit about what happened working as a network engineer in my first job. And I want you to have it as an experience so it doesn't happen to you whenever you're working in the network operations center or any position as a network engineer. Remember to write down the information in the ticket in order to have um, everything documented as best as possible in order to avoid this kind of inconveniences or even so lose your job because you are not documented everything that is happening in the tickets. So this is my anecdote for today. I hope that you have learned from it, that you like it, and let's start with the lesson. So first thing we do, let's look at the addressing table that we have here. Okay, we have router 1, router 2, router 3. Some of these is pre-configured. We have the virtual gateway, two switches, some VLANs, some PCs, and a web server. In this packet tracer activity, you will learn how to configure hot standby router protocol HSRP to provide redundant default gateway for devices to host on LANs. After configuring HSRP, you will test that configuration, verify that hosts are able to use the redundant default gateway if the current gateway devices become unavailable. Configure HSRP on the active router, configure HSRP on the standby router, verify HSRP operation. Background scenario. We will be running spanning tree. We will be working on first hop redundancy protocols and configuring some VLAN information, the virtual gateway information as well, step by step. So the first thing we have to do is go to PCA and open command prompt. So let's go ahead and do that. Let's go to PCA and go to command prompt. And this is the first thing we have to do. Send a tracer. Send a tracer to 209.165.200.226. Let's be patient. It can take a little bit of time. Remember that the tracer command, it might take some time because you are from source to destination receiving all of the hop's information, and there you go. Now we have the first trace completed, the tracer, which devices are on the path. And here we have R1, R2, and the iNet. Those are the devices. You can see those. Let's validate in the routing table. In the addressing scheme, 192.168.1.1 is actually router 1, in fact. Then the 1.1.2 is actually router 2. And then 10.100.100.2 is actually the iNet. There is even a 209.165.200.226, which is the web server. So we can add the web server as well. Now, if we repeat these we are going to get the same information in computer B. In fact, let's go ahead and copy this command and let's go to computer B so we can do it there. Look at that. It is almost the same information, but there is another router. We have R3, R2, and the iNet, as well as the server that we are reaching. Now, you can see actually all the path there. First, we have router 3, then we have router 2, then we have the iNet, and finally the web server. That's the first thing we have to do. Let's see, let's see if with those small changes we are getting any completion. No. So next thing we do, select delete from the packet tracer toolbar and delete the link between R3 and S3. Okay, let's take a look at that. So they are asking us to delete between R3 and what was the other one? Do you guys remember? And the switch 3. Let's see, we can see it there. R3 and the switch 3 is actually this one. So let's see if we can delete those. I think it's blocked. No, it is allowing us to do it, so great. Now, what else are we doing here? We have to execute the tracer with the web server to the destination. Hmm, the destination. Let's see. Let's go to the web server. Let's try to reach, let's try to reach PCA. Let's try to reach PCA from this web server. Let's do a test here. Let's go to the web server. It's not letting us access the web server. That is interesting. Let's see, we can connect via terminal, but this is strange because we should be able to access the web server to do the ping test. Let's do it the same test that we did before to reach the web server from the PC. Let's just ignore the instructions for now. Let's see if this works or not. It might actually work with a little bit of more latency. Will it work? That's a big question. I don't think it's working. We are not getting connectivity there. We are getting requested timeout. Hmm, interesting. Okay, let's just ignore it for now. Basically, now that the path is broken, we're not getting connectivity and locate and select the copper straight to cable and click the 0 gigabit 02 and 00. Okay, so we have to connect the straight through cable. Do you guys remember what was the straight through cable? It's this one. Gigabit 02 here, 00 on router 3, and gigabit 02 on switch. Now, if we do the trace, let's just wait for a moment and try to run that trace again. Let me see if eventually control chip 6 maybe. We have to be patient. Let's try another PC because this one is taking an eternity. Let's try to do a ping test first. 209.165.200.226. It is actually unreachable. Let's wait one more time. Hopefully it will. Oh, that is not the right IP address, or is it? No, it's not the right one. Take a look at that. It's a 5 instead of an 8. Okay, now let's do the same one here. Let's do a ping test to see if we have full connectivity to the 209.165.200.226. Great. It's successfully completed from the source to the destination, and those are great news. You can actually see the full connectivity at the end. all pings are being successfully completed and we have the full reply and the time and everything. Great. Zero packet loss. Now we have to start doing some configuration. So we have to go to router one and let's see if we have full access to router one. Sometimes it's blocked and we have to access by a terminal with console cable, but in this case it's currently available. So let's take some advantage of that. Okay, we are configuring 01 standby version 2. That's the first command. Then we have to add this IP address. Let me just copy and paste it for improving the speed purposes of this lab. And next thing we do is standby one priority. And this is 150. So we configure as previous lessons in the theory. We start with the IP address, then we did the priority, and we have to do the preamp value. In this case, the preamp value, we have to do it with the standby one preamp, and there you go. Great. What will HSRP priority of router 3 be when it is added to HSRP group 1? 100, because this is the default value. But for now, let's just do an ent and a WR to save the configuration. And let's continue moving forward. Now we have to move to router 3. Let's go to router 3 and let's start adding some of the configuration there. Enable, then we do a config T. Interface gigabits 0100. Standby version 2. Now we execute standby 1 IP 192.168.1.254. And there you go. Amazing. Good job. Now let's do an end and a WR just to save our configuration. And let's move back to router 1 for now. Let's move to router 1. You can see we have already 60% of the lab completed. Now let's execute show standby. Show standby. And there you can see the following information. You can see that it is in group 1, effectively version 2. You can see the virtual IP address. Let me just erase it for a moment so I can highlight it better. Let's use another color. Okay, you can see the IP address right there. Then you can see the local virtual MAC address and the active MAC address. You can see the preemption, which is enabled, the standby router, the priority. That's pretty much everything. Now, let's clear the board for a moment and let's go to our other router. Let's close this one and do the exact same command here. Show, standby, and enter. What do you guys think we are going to get here? It's pretty much the same information. We are in group 1, version 2. Then we have the virtual private IP address, the MAC addresses information. The preemption is enabled, and there you go, the active router. In this case is 192.168.1.1, which is the IP address for router 1. And the active router here is local in the other one, but you can see it's actually 192.168.1.3 in router 1 is the standby router, which is our router 3 in this scenario, in this case. Let's keep learning about this, clear the drawings for a moment, and let's continue moving forward. So we can actually remember the router 1 was the active router. The MAC address, do you guys remember what was the MAC address for the virtual IP? Let's go back to that topology and validate that. Let's go to router 1 and let's take a look to validate if we are getting the same one. Yes, the active virtual MAC address is there. It is that one. quadruple 0C9F F001. That is the MAC address. Then the standby router, we already went over that one, is the 1.3 IP address. And the priority is 150 here, but if we go to router 3, we might be able to validate the priority is 100, which is the default priority. Great. Let's do a show standby brief in router 1 for now. Show a standby brief. And you can see some of the information. Let's go ahead and clear the drawing for a minute. And here you see the virtual IP address. Let me show you guys. Let me expand this for a moment so you can see it better. And then you have the standby and the virtual IP address. We're working alone in router 1. It is active and local, 154 the priority. In configuration is actually in gigabit 01. That's pretty much what we have here. Now, what else do we have, boys and girls? Let's clear the drawing and let's go ahead and do the exact same processes, the same command in router 3. Let's go to router 3. And we're going to expand this for a moment. Let's do a show a standby brief again. And there you have it. Now we're working with router 3. Remember that? Gigabit 00, priority 100. This is the standby. This is the active router, the local, and the standby local, which is our standby router. And what else do we have? We can see the active router is router 1 as well, the virtual IP address for router 3. In this case, gigabit 00. Group 1, version 2. We can see pretty much the same information that we have been validating so far. To change the gateway for PCA, PCB, switch 1 and switch 2, which address would you use? In this case, we will use 192.168, the one that 254, in case that change is required. And we need to move from the active router to the backup router. Okay, great. Let me just go ahead and erase the drawing. And let me go back to the red color for a moment. Let's close the window. We have to configure some information in switch 1 and 3. So let's go ahead and configure those guys. First thing, we go to switch 1 and we execute. We execute configure terminal, IP default gateway 192.168, that 1.254. Let's do an N and a WR. The exact same configuration, let's just copy and paste it in the switch 3. So let's go to switch 3. Okay, let's do an enable. Let's do a configure terminal. And let's paste it there. Great, congratulations. You're doing such an amazing job. Now, let's go ahead and configure the IP address for PCA. Let's look it up. Let's go ahead and do the 2WR here. Let's do a WR on switch 1, switch 3. Great. Now we need to move along to configure and validate the configuration for this PC. Let's validate. Everything looks great. Now we need to do a small brief change. The default gateway will be 254 PCA. Same thing happens with PCB. The default gateway now it will be 1.258. 254. I mean 254. Maybe I was saying it correctly. The default gateway is 192.168. The 1.254. Yes, 254. Great. Verify connectivity between both PCs. So let me send connectivity from this PC. Let's go to the first one and do a ping test. Let's do a ping. And it is successful. Now, let's do an IP config and let's do a connectivity ping test here. Let me go there. Let's do a ping test. Now we will be changing the 3 for a 1. And there you go. There you have it. PC1 and PC3 are connected successfully. Now it says that, yes, the path now passes through router 1 instead of router 3. Maybe we can do the tests in PCB. Let's do a tracer to validate this. Let's do a tracer and see what happens. We are going to go to PCB. Now you can see that it goes um, to router 2 and then, if I'm not mistaken, to router 3 and then to the server. Let's just validate what was the IP address for router 3 that we have there. This is router 2. This is actually not router 3. What is this one, guys? What is this IP address? 10 that is the INET IP address. So how do we know it's going to router 3? Let's validate that. We So let's validate R1 instead of router 3. Okay, so now we can actually validate is traveling via router 1 instead of router 3. And that is because of the priorities that we have been doing with HSRP. And that's basically what we're seeing here. Now, at first, at trace, there is a timeout. Where? Do you guys see a timeout here? I don't see any timeout. How was this trace different from the previous trace? Immediately return to PCB and execute this one again. Let's see if running the trace route, let's go ahead and trace route again. But we are not getting any timeout. Hmm, Let's do it one more time. Yeah, it's working perfectly. Maybe they are talking about when we started the lab. Let's see if we got some timeout when we started the lab. Yeah, we were getting some timeouts at the beginning of the lab for some reason. Maybe they are referring to that at the beginning of the lab. Is this the same IP address? Hmm. Oh, is when we actually disconnected the cable. We were getting the timeout because we disconnected the cable. That's very much what happened. But then we disconnected the cable, we were getting that timeout. But besides that, everything has been working properly and perfectly. So let's go ahead and see. Oh, okay, they are saying the same thing that we have to. Let's go ahead and do the test. They want us to do this. They want us to delete the cable. They want us to delete the cable here, and they want us to do the test. So let's do the test one more time. Hopefully in the next few seconds or minutes, we will be getting that timeout. You can see the asterisk now, and that's what they want us to do. They want us to get that timeout. And right now it's moving to the backup router interface, which is in router 3. So let's connect that again. Do you guys remember how to connect it? That's a big question. Let's see. I don't see it. Router 3. That's a great question. We pretty much configured the lab, but I don't remember how to connect that. Let's see, and we completed the 100%. It was a straight through. Let's do the same thing. Gigabit 01 and gigabit 02. There you go. Let's do the test one more time to see if now it passes through router 1. And the first thing we do it, you can actually see is still going to router 3 because it takes a little bit of conversions. We need the router 1 to become the active router again. Let's see if we can, in the meantime, do a Just stand by here to validate if this one becomes deactive again. Just stand by. Now it is the local. The standby router resume no. Let's see one more time. It takes some time. Let's see in router 3 to see what we have. We are running the extra mile here. And this is actually the standby router local now is finally getting back to normal. And if we do the trace again, it will go via router 1. Look at that. We have been successfully completed several failover tests. And we finally understand in real life how the failover works. When one connection goes down, the other one backup comes into play. Amazing. We have learned a lot from this lab today. Wow. It was a pretty neat lab. I like it. And this is the configurations that we have been adding so far. In this website, you can download the Packet Tracer completed lab. In fact, um, let me go ahead and download it so I can share it with you guys later and have it there available. I'm just going to name it something like completed. Yeah, let's do that. Let me just name it like completed. So you will have this lab along with the instructions and everything that we have done so far today. I hope that you like my anecdotes that I was telling you about at the beginning of this lesson. I hope that you enjoyed this lab and learned a lot from it. And I will see you at the climb of success, at the top of success, boys and girls. Remember, practice makes perfect. Take care, boys and girls. Goodbye.